Welcome. My name is Ron Papa Schmidt, and I'm the creator of the Net Zero Now YouTube channel. And this is going to be an abbreviated or a short version of session 2, which focused on why now. And by now, I mean urgently, sort of as quick as humanly possible. Because I understand that getting to net zero greenhouse gases is going to require money and time to do that, okay? Now, I want you to do something here, and I want you to maybe pause this video and write down the name of at least 5 people that you truly love that will be alive 25 years from now in 2050. So why don't you do that? Pause the video, write down their names, their ages now, and their ages in 2050, and then start back up on this video. So the key slide in this session is really this graph of average temperature, global temperatures. And you can see that we've increased from 14.6 degrees Celsius to 15.1 degrees Celsius, or half a degree Celsius in the last 10 years. And basically, we've gone from 58.3 degrees Fahrenheit to 59.2 degrees Fahrenheit. I'm using Fahrenheit because as Americans, we just can't relate to Celsius, okay? But an interesting thing happened. At 51.1, that happens to be exactly equal to 1.5 degrees Celsius from pre-industrial ages that the Paris Climate Accords talk about, and so much literature talks about, climate change talks about. And in those accords, it said we weren't going to hit that level until the goal was to make sure we didn't hit that level, rather, until 2050. And they said the goal was under no circumstances did we want to hit 2 degrees Celsius, but if we did, we didn't want to hit it until at least the year 2100. So let's jump forward here. This is a graph of average temperatures. The reason I'm showing you this is average temperature is not the temperature in one city or one point on Earth, okay? We're talking about temperature change. We're talking about temperature around the globe, and it's the average of temperatures of various different spots in the ocean, over land, and in the Arctic. And those all get averaged together for an average temperature. And you can see, incidentally, here that the Arctic is warming faster, as is land warming faster than the ocean. And then the other point I just want to mention for a second here is that when you look at information, you do a Google search, for example, it may very well tell you that our average temperature is only 1.2 degrees Celsius. And I'm saying it's 1.5. Well, it turns out that both numbers are right. The 1.2 degrees Celsius represents the 60-month moving average, and what I'm talking about in these presentations is the actual temperature in the month of November. So that is the difference. So, and you can see there's quite a difference between the two. That shows you how fast our temperatures are rising. If you can, we're about 25% higher than the average, 5-year average right now. And so I just want to mention that point. So when you see information, you need to really, in graphs and other kinds of things, you really need to figure out what are they really talking about, okay? Now let's go to the next slide. So all I did here is I took this graph and I said, okay, so if we increase by 0.9 degrees Fahrenheit in 10 years, when would we hit these sort of milestones that science literature talks about, 2 degrees, 3 degrees Celsius, and 4 degrees Celsius? And it turns out in 2034, we would hit that level, which is equivalent to 60.1 degrees Fahrenheit. And we'd hit 3 degrees in 2054 and 4 degrees in 2073. Now, the question is that a reasonable assumption? My guess is probably too conservative. And here's why. Almost every time the climate models are compared to actual results, climate models are almost every single time underestimating the pace at which the temperatures are warming or ice is melting, etc. And there's a reason for that. We'll talk in the scientific section. And another thing that's probably working against us right now is that a lot of our political leaders in the United States and other countries, along with many of our industrial leaders, are really sort of de-escalating or de-emphasizing climate action. In some cases, we're actually reversing some prior climate actions we took to try to reduce global greenhouse gases. And then you have something called feedback loops that can just accelerate the pace at which we add greenhouse gases to the atmosphere. And examples of those quickly would be the Amazon rainforest, Greenland ice sheet melting, permafrost melting, forest fires, etc. And let me just give you a real quick example. So in the Amazon rainforest, the trees serve as a sink. They pull carbon dioxide out of the atmosphere. So as we cut down the trees, we pull less greenhouse gases out of the atmosphere, right? Well, the other thing happens, then we use that land for farming, in a lot of cases for cattle, which generates significant amount of methane or another greenhouse gas into the atmosphere. In addition to that, the logs that we cut down were a reservoir of greenhouse gases, so we burn them, and so what happens is that greenhouse gas goes into the atmosphere, which sort of accelerates the pace of global warming. And so that's what we mean by feedback loops, and we'll talk about that in session 3. And then there's such a thing as cascading feedback loops, where a feedback loop, for example, in the Amazon rainforest could affect Greenland ice sheet melting or permafrost or other kinds of things and cascade throughout the entire Earth's climate system. So I created this graph of accelerated growth, and all I did here is I looked at the chart and I said, if I looked at the chart, we had 2 COVID years where nothing happened. So I just assumed we'd increase by 0.9 in 8 years as opposed to 10 years, and then calculated when we would actually hit these levels. And I just I upped the number by 1/10 of 1 degree every 10 years. And that sort of gave us a faster rate. Maybe we'll end up somewhere between there. It's possible that these numbers, even these accelerated numbers, may be too conservative. So where does that leave us? So where that leaves us, when we hit 2 degrees, here's what I'm just going to read you the conclusions here, okay? And that's at 60.1 degrees Fahrenheit, the world will see catastrophic and likely irreversible damages. That means that it's possible that there's nothing human beings can do to prevent our temperature from continuing to accelerate out of control. And when's that going to happen? It could happen as early as 2032 to 2034, less than 10 years from now, or about 10 years from now. So what happens at 3 degrees Celsius? When are we going to hit that? Well, somewhere between 2047 and 2050. And remember, I asked you to go back and identify loved ones who would be alive this year. And I did that because human beings are incapable of relating to future years and future risks. So think about those people when I say, here's what happens in that year. They call it a nightmare scenario. Now, let me jump to what happens at 4 degrees. That will occur about could be 2070 in that area or so. It says at that point, the world is a planet unrecognizable to human beings. So if you have loved ones, they're going to be alive then. Is that really the kind of Earth you want to leave them? I mean, I don't know how in good conscience we can continue to ignore this problem. And that gets us to, I summarized that information here now to just emphasize why we need to get to net zero greenhouse gases now, why we need an all hands on deck effort. And so I said here, as we talked about, again, think about your loved ones. Do you want them to live in a livable Earth, or if we follow our current path, this is where we're going to be at? And then I would ask you to continue to watch and subscribe to this particular channel. I just want to add one other thing here. As I talk about in all of the long videos, I'm not a climate scientist, okay? But I've done a lot of research, and I believe what I'm reporting is accurate. And in the long form of the introduction, I actually will show you what resources I used, etc. But it's possible I'm wrong. This is an incredibly complex subject, and I may not understand it. I have a simplistic view how the world operates, and I could just be wrong. So I ask you to use some discernment and check it out. Do your own research. But if you think that what I'm saying is correct, even if I'm off by a couple of years, it doesn't matter, then you're going to need to get involved and really do something. So thank you very much, and hope to see you in the next session.